Hello everyone. In this video we are going to learn about how to design and implement a Discone antenna for indoor use in digital TV receiving and broadcasting system. This type of antenna are wide bandwidth and omnidirectional radiation antennas, and also it is widely used in VHF and UHF broadcasting system. Let us see the script, Matlab script for this design. This program contains the first part is called define the parameters, and second part is create discord antenna, and third one is analysis purpose, find the S parameter analysis and radiation pattern and elevation pattern. Finally you see the output for this type of discount antenna for TV broadcasting system example. Okay, first you define the parameters. These parameters helps to design discount antenna to cover the frequencies between 470 megahertz and 862 megahertz, which is the ultra high frequency band of this TV broadcasting systems. It refers RT refers radius of the disc, and RC1 refers broad radius of cone, and RC2 refers narrow radius of cone, and HC is the height of the vertical height of cone, and is a feed width, and it is a spacing between cone and disc. Here the radius of the disc and broad radius of the disc and narrow radius of the cone are defined by using this first part of the script here. The next part is create discount antenna. Here used to define the parameters here. These are the parameters: antenna, discount antenna. These are the functions are there. According to the parameters, we can create the discount antenna. After executing this antenna, you can see the discount antenna element like this. The next one, the operational characteristic of the discount antenna are mainly depends on the broad and narrow radius and height of the cone. So in this example, the minimum operating frequency is 470 megahertz. The higher frequency of the discount antenna is mainly determined by the size of the narrow radius of the cone, and the gap between the cone and the disc. Here the spacing is, you can set the 1.75 into 10 to the power of minus 3. Okay, these dimensions will control the input impedance and is used to guarantee impedance match of this design, so that this antenna is said to be a good performance when the reflection coefficient is below 10 dB. Let's see what happened during the simulation. There is a good impedance match from 460 MHz to 2.3 GHz. When you plot the S parameters over a wide range of frequencies, you can observe wide band characteristic of discount antenna system. Let us see the same simulation part. You will get this type of output. These were S parameter output. This is a frequency SS, magnitude output. Here you can see there is a good impedance match from 460 megahertz to 2.3 gigahertz, so that here the reflection coefficient also it shows the below minus 10 dB. It's a reflection coefficient below minus 10 dB, so that you can set to be in good performance in when the reflection coefficient is below 10 dB. When you plot the S parameters over a wide range of frequencies like 2.3 gigahertz, you can observe the wideband characteristic of this discount antenna. Let us see the radiation pattern. This is a radiation pattern of this discount antenna. Here you can see the output directivity and frequency range is 470 megahertz. Okay, this plot radiation pattern at 470 megahertz is shown here. This pattern is omnidirectional from 470 megahertz to 862 megahertz with the gain ranging from 1.75 dBi to 2.3 dBi. Here what is the dBi? The forward gain of the antenna measured in decibels. The dBi value reflects the antenna's directional or beam width characteristics. Due to omnidirectional characteristic, the discount antenna is used in VHF or TV broadcasting system, so that this type of radiation pattern plotted 470 megahertz. It is a omnidirectional pattern. The gain ranging from 1.75 dBi to 2.3 dBi is a azimuth angle, and also the elevation also there. This elevation pattern is the 2D radiation pattern of the antenna. This radiation pattern, minus 180 degree to 180 degree azimuth pattern is there. Is omnidirectional is azimuth plane, and bidirectional in elevation plane. Then let us see the next one. This is a cone diagram. Then next one. This is where directional pattern. This elevation pattern. It's called two-dimensional radiation pattern of the antenna. It shows between this blue line 470 megahertz and 862 megahertz and 1,001.5 gigahertz and 3 gigahertz. Now let us see this radiation pattern is omnidirectional in azimuth plane and bidirectional in elevation plane. So what is the conclusion of this antenna design is the antenna provides matched bandwidth below minus 10 dB of return loss between 460 megahertz and 2.3 gigahertz, and also it provides omnidirectional radiation pattern within the considered TV band from 470 megahertz to 862 megahertz. So that in this case this type of antenna used for indoor TV receiving and broadcasting system. Here after run this section, you can see these are Discone antenna parameters. Here itself we can insert color bar and all. Here the radius of the disc is 55 into 10 to the power minus 3, and the broad radius of cone and narrow radius of the cone, and vertical height of the cone and feed width and spacing between the cone and disc are described here. And next this one, what is the S parameter of this cone. Here there are calculating solution for 291 frequency points are shown here. Here it shows after running this frequency sweep, you can see the S parameters versus antenna versus plates. Also this RF plot command used to plot this S parameter value. In meantime, you can see what is the function of this RF plot, RF plot, what you can see. In this program, you can see this RF plot function are used to plot the S parameter value, and these were radiation pattern. This is the function radiation pattern at antenna versus your frequency. What is the desired frequency we set is 470 megahertz. Then elevation pattern. What is the if you want to draw the polar pattern, means you use this function polar pattern, and finally you can set the legend value of this 470 this frequency between 862 and 1.5 gigahertz to 3 gigahertz. Let's see, take some more time because the frequency point is calculating, so that it takes some more times to get calculating this frequency points. Then after calculating this frequency point, you can see this frequency versus magnitude curve. This is a S parameter value, X parameter pattern. Here you can see this before 10 dB. The reflection coefficient is below minus 10 dB, so that we can say there is a good impedance match from this 470 megahertz to 2.3 gigahertz, up to 2.3 gigahertz. There is some good impedance match, so that this type of antenna, that is for Discone antenna, perfectly used for indoor digital TV receiving and broadcasting system. You can see 2.3. Still it calculating this 79 to 80 frequency points. It takes some more time. RF plot. Okay, here this RF plot command, it's plot the S parameter data. These are all the syntax we are seeing. This yes underscore object plots the magnitude in decibel versus frequency of all the S parameters like S11, S12 at SNN on the current axis. Here if you use for RF plot S underscore object and comma I comma j, it plots the magnitude of Sij in decibels versus frequency on the current axis. Here is the input. Si means input port, j means your output port. These are RF plot hyphen comma line spec means it plots S parameter using optional line types and symbols and the colors specified by the line spec. Then similarly the next one, RF plot hyphen comma plot flag. This command allows to specify the type of plot by using plot flag. Similarly the H line RF plot in brackets you give the S parameter value. This plots the S parameters and returns the column vector of handles to the line objects. This is H line. Similarly, these are examples are there to get this plot the parameter for using RF plot command. Here for that you need RF toolbox. Here just you can see these were S parameter of this default values. Default parameters are given in this label. You can set this RF plot. This is a plot between frequency versus amplitude. Is a one function is available in RF toolbox, especially for antenna design and analysis. Let us see 150 frequency points are there. By using this interactive plate, you can also use some tools. You can also edit some plots. You can insert the labels in x-axis and insert the label in y-axis, and also insert the color bar here. Insert the color bar. You make this plot interactively by using these tools. You can utilize. You can also include insert line, insert arrow, insert text arrow, and what is a double arrow you can insert, and rectangle ellipse. For example, text arrow I want to check with this check arrow. This one check arrow takes some more time for responding because parallelly running there. Can here in this manner you can make your because parallel is running, so that it takes responding. Here you can mention the frequency point here 2.3 gigahertz at 2.3 gigahertz from 460 megahertz, the good impedance match, so that in this manner we can make your plot as interactive. In this radiation pattern, elevation pattern is a P1, P2, P3, P4 is there are four type of elevation patterns we are drawing with this two-dimensional radiation pattern of the antenna here. First one is with 470 megahertz and 862 megahertz and 1.5 gigahertz and 3 gigahertz. Here we are making as two-dimensional radiation pattern as a elevation pattern. This type of radiational pattern is omnidirectional in azimuth plane. This one, first one is azimuth plane, and bidirectional radiation pattern in elevation pattern. Let us see at the time of simulation. We can understand very easily. In this S parameter section, you can identify the frequencies. You start from 0.1 to 0.0.1 is the step frequency, and finally at 3 gigahertz in the 1 gigahertz. Here you make the mesh pattern, and finally the S parameters as antenna versus frequency by using the RF plot of S1. This is where S1 is where S parameter of this particular Discone antenna element. Now almost it calculating all the frequencies sweep. This section is create Discone antenna. Now let us complete up to 254 frequency points from 291. Almost it's we are nearly seeing the simulation. This type of antenna design and analysis for indoor digital TV transmitting and receiving systems as widely used for this wide bandwidth and omnidirectional radiation antennas, and also it is used in VHF and UHF broadcasting system. In this example, we are taking this minimum operating frequency of 470 megahertz, and the higher frequency of the Discone antenna is mainly determined by the size of narrow narrow radius of the cone and the gap between the cone and the disc. Okay, this dimension only will control the input impedance and used to guarantee impedance match of this one. Now the output is coming, the frequency sweep calculation is over. The first we are getting this S parameter calculation. As we said, as we discuss later, by using this here itself you can give the S parameter analysis. Directly you can insert S parameter analysis. Also you can insert the title and the legend, and also you can insert the color bar also to make this interactive plot. You can see what is the point each and every point. That is where what you discussed in good impedance match from this 470 megahertz to 2.3 gigahertz. Also you can make it as you can insert the arrow. There's a text arrow. You can see here itself you can give the text arrow. These were maximum at 2.3 gigahertz. You can insert 2.3 gigahertz. Okay, in this manner you can set we can see the minus 2 low bandwidth. Also you can insert the line here. It's also insert the line here, minus 10 dB line. In this manner you can make interactive plot for this one text arrow. Also you can make the double arrow here. You can give the double arrow in this manner. You can make your plot as interactive one. The next plot you can see the antenna design. First one, define the parameters. In the first section it shows in this workspace where the values parameters are added. The next one, by using this section you can see the Discone antenna element. Here itself you can insert the color bar, you can also insert X label and Y label, you can give the title here, you can make it text arrow and text box and rectangle ellipse, etc. For example, this was line, you can insert the line, insert your text arrow. In this manner you can add this one, that is your disk. In this manner you can make your plot as interactive. And the next one, these are find a X parameter value, and the next one is the radiation pattern. In this radiation pattern you can see the output of the radiation pattern at 470 megahertz. This pattern is omnidirectional from this 470 megahertz to 862 megahertz. It shows the antenna, right antenna, overlay antenna. Options are there. Here you can see the overlay antenna. And the next one, let us close this one. Similarly, you can see the elevation pattern of this test antenna. Takes some more time to respond. Now it is coming. This is your elevation pattern. It's nothing but the two-dimensional radiation pattern of the antenna. It shown for 470 megahertz and to 862 megahertz and 1500 megahertz and 3000 megahertz. What we mentioned as a elevation pattern like in this program. Here we can set the plant elevation pattern, antenna pattern for 470 megahertz and pattern elevation for 862 megahertz, and the third one P3 pattern elevation for 1.5 gigahertz and 3 gigahertz. So by using this example you can set the designed antenna set to be in good performance when the reflection coefficient is below minus 10 dB. So there is a good impedance match between 460 megahertz to 2.3 gigahertz. So what is the conclusion of this design is the antenna provides matched bandwidth below minus 10 dB of return loss between 460 megahertz and 2 gigahertz, and provides omnidirectional radiation pattern within the considered TV band from this 470 megahertz to 862 megahertz. Okay, here itself you can make it as interactive plot. Here also if you right click on that you can measurements with the add cursor option, also there angle, and you can see see the auto limits. You can make the properties, you can display. It's a tiles display or show legends. In this manner you can make your plot as interactive for each and every data set. You can insert. Here also you can insert the color bar. Here also you can insert line arrow and double arrow. What you have to specify as a text box, you can interactive manner you can set. I hope you enjoy this video. Thanks for watching. If you are new viewer of my channel, means kindly subscribe my channel, and don't forget to like and share your friends and your students. Thanks for watching. Thank you.